Okay, folks, so here we go. This is Calculus, Chapter 1. It is titled A Preparation for Calculus. So basically what we're looking at here is we're looking at Chapter 1 being review. So these are things that you should already know how to do. So we will be moving kind of fast. It'll slow down when we start Chapter 2, which is actually new material. All right. The objectives for Section 6, the objectives for Section 6.1 are going to be sketch a graph, find intercepts, symmetries, intersections, and interpret mathematical models for real-life data. Okay? All right, we're going to start out with the graph of an equation. Consider the equation 3x plus y equals 7. The point 21 is a solution point. There's a term for you, okay? So we're talking here about terminology. Okay? Unfortunately, a realization that you're going to have to come to is that as the math gets more complicated, the terminology is necessary. Okay? So it's going to have to get more complicated. So we're going to be using terminology, or I'm going to be using terminology, and the expectation is that you will just know what that terminology means. And because calculus is complicated mathematics, there's going to be lots of terminology we'll be using. Okay? So what does it mean to say it's a solution point? Well, a solution point means that if I were to take this ordered pair and to substitute those values into that equation, then it would be a true statement. So that would mean that 3 times the value of 2 for the x variable plus 1 should be equal to 7. And indeed, 6 plus 1 is 7. 7 is equal to 7. So that is a solution point. Right? Given that this is an equation on 2 variables, there is the possibility for multiple, or infinite for that matter, solution points. And there are other solution points. For example, 1, 4, and 0, 7. The ordered pairs 1, 4, and 0, 7 are also solution points for that equation. If your job was to find solutions, one way to do that systematically is to solve the original equation for either variable. Now, traditionally, we usually solve for the variable y. We call that the dependent variable, and x the independent variable. So that same equation solved for the dependent variable y would turn from 3x plus y equals 7 into y equals 7 minus 3x. And then one way, an old school way of doing it, would be construct a table of values, and then by inputting or substituting several values for one of the variables, in this case the dependent variable x, and then solving for the corresponding value of y. So if I were to pick, I don't know, well, we've already done 0, 1, 2, so how about negative 1, negative 2, how about maybe a 3, a 5, and a 6? We could solve for all those values. So we're just going to go ahead and do that really quickly. We're going to solve for some solution points. Okay? So the first one I'll do is when x is negative 1. Then y would be equal to 7 minus 3 times a negative 1. That's 7 plus 3. And that's going to be 10. So then a solution point would be the ordered pair, negative 1, 10. Similarly, if I wanted to find the value for the solution point for when x is negative 2, I would get y is equal to 7 minus 3 times negative 2. That's going to be 7 plus 6. That's what, 13? And so that a solution point would be negative 2, 13. If I wanted to find a solution point for when x is 3, I would have y is equal to 7 minus 3 times 3. Let's see, what's that, 7 minus 9? So then I would get that y is equal to, is that negative 2? Negative 2. Okay. So I'm just plugging in values for one of the variables and solving for the other variable. Last one, 6. Let's see, I've got y is equal to 7 minus 3 times 6. Y is equal to 7 minus, is that 18? Y is equal to negative 11. And so then I've found all of these values, which each of those ordered pairs represents a solution point for our equation. Okay, so let's review what we've taken a look at so far. the graph of an equation. The graph of an equation is a collection of points that are solution points. So what's a solution point? It's an ordered pair of values to represent the variable values that make the equation a true statement. Okay. Like many equations, this equation has infinitely many solutions, an infinite number of solutions, and if we were to put all those solutions together, we would get a graph of the equation. So if I were to take all those points and to graph them, I would get a solution. So we'll start with the first one. Okay. The first one said when x was 2, y was 1. And then we had a couple other solution points. What did we have? We had negative 1, 10. So when x was negative 1, y was 10. 3, 4, 5, 6, 7, 8, 9, 10. So way up there. And if I plot a couple more points, like when x was 1, what was it when x was 1? When x was 1, y was 4. So when x was 1, 1, 2, 3, 4. So right about there. And then if I were to draw the straightest of lines through those, that line would be the graph of the equation. Now, I would like to refer to this more as a sketch than a graph because I think that a graph is more accurate than what I just did. And in fact, if I wanted to graph this, what I would do is I would probably go to something like this and graph my equation here. And what was my equation? My equation was 3x plus y equals 7. And then I could manipulate this and make this show this however I wanted to show this to get that graph a little better. I could talk about those two values right there, those important points. And then this I would refer to as a graph rather than the sketch that I made over here. Okay. Now, the thing to keep in mind is, though, that the set of all the solution points, all shown at once, is the graph of the equation. Okay? We have our axes here, the horizontal axis x, the independent variable, the vertical axis y, the dependent variable. Okay? So what I would like to do is I would like to take an example here, and I would like us to sketch the graph of y minus x squared is equal to negative 2. Okay? So I'm going to go ahead and clear this sketch, and then we'll make that one. Okay? So y equals, let me move this out of the way, y minus x squared is equal to negative 2. Sorry, I keep saying that wrong. I'm not used to that format. So first thing I'm going to do is I'm going to take that equation and I'm going to rewrite it so it makes sense to me. And I'm going to say, well, that means y equals x squared minus 2. And let's see, I think this is a parabola because of the exponent there being a 2. Okay. So I would sketch this as a parabola. There are many ways I can go about sketching this, but I'm going to repeat what we just did, and I'm going to use a t-table, sometimes they're called, and I'm going to come up with some values for x, like say negative 2, negative 1, 0, 1, 2. And I'm going to see what the corresponding y values are. What would be the y value if x was negative 2? Well, the y value would be negative 2 squared minus 2, which is 2. Negative 2 squared is 4, 4 minus 2 is 2. What about if it was negative 1? So negative 1 squared minus 2. Well, that's going to be what? Negative 1 squared is 1 minus 2 is negative 1. Okay. How about if x is 0? That's going to be 0 squared minus 2, which is negative 2. How about it 1? That would be 1 squared minus 2, that's negative 1. 2, that's going to be 2 squared minus 2, that's 2. Now I'm going to take those values over to my graph here, and I'm going to graph them. Looks like I need to have 1, 2, negative 1, negative 2. Let's see. Negative 1, negative 2, 1, 2. And let's start putting some points over here. I'm going to use green. Let's see. When x is negative 2, y is 2. When x is negative 1, y is negative 1. When x is 0, y is negative 2. When x is 1, y is negative 1. When x is 2, y is 2. And there's my lovely parabola. And that parabola, that graph there, is all the solution points for that equation. All right. So the solution process we use there is we solve the equation analytically for either variable, usually y. We constructed a table of values, and we plotted the points shown in the table, and we connected points, and we made our graph. Our graph is a parabola. Right? So how do you graph things? That's basically the process. Right? I'm doing things by hand. That's how I do it. If I wanted to graph this thing using some sort of technology, I could come over here and graph it. I have y minus x squared was equal to negative 2. Okay? And then I can change the horizontal scale, zoom in, zoom out, make this thing look how I want it to look by showing the parts of the graph that I want to show. Represent the things that I need to represent, and go from there. So my job is to be able to graph an equation. Now, once I have an equation graph, then I want to start talking about the important features or the important aspects of that graph. One of the things that we are constantly asking for is these things, the intercepts of a graph. Okay, so solution points that are useful for graphing and elsewhere are solutions having 0 for either the x or the y coordinate. Right? These are called the intercepts because they are when the graph of the equation intersects either the x-axis or the y-axis. The number of each type of intercept vary with the equation is being graphed. Right? Now, I want to be careful about this because this starts out by saying 2 solution points, and really it should be 2 types of solution points that are useful for graphing, because it isn't just that there are always 2 points, it's whatever it's got. So like if you take a look at our pictures here, this one has 1 intercept because it only crosses the y-axis. This one has 3 intercepts because it crosses the x-axis 3 times and the y-axis once. This one has 3, but it crosses the y-axis twice and the x-axis once, and this one has 0. So they're not that every graph has 2 intercepts. Every graph has the potential for 2 types of intercepts. Right? Now, about intercepts. When a graph crosses the x-axis, that means that the y-coordinate or the y value is 0. When a graph crosses the y-axis, that means that the x-coordinate is equal to 0. So that tells me that when I'm looking at a graph like this, I know that this intercept right here is going to be something of the form 0, number. And given that we're above the x-axis, I know that that number is positive. When I look at this graph right here, I know that this guy is going to be an x-intercept, so that's going to be some number, 0. This one over here is also going to be some number, 0. And it appears that one right there is crossing the origin, which would make it 0, 0. What are we looking at here? Oh, I'm looking at 2 y-intercepts, 1 x-intercept. So both of these are going to be 0, some number, whereas that one is going to be a number, 0. So I need to be comfortable looking at a graph and saying, hey, if it intercepts here, if it intercepts there, if it crosses the x-axis here or crosses the y-axis there, what would the coordinates or what would that solution point look like? So how do we solve for intercepts? Well, the way that we solve for intercepts is we look for those places where it crosses. If we're looking for x-intercepts, well, what does it mean to find an x-intercept? An x-intercept where it crosses the x-axis. If it crosses the x-axis, then that means that y must be equal to 0. And so what I'll do is I'll put y as 0 in the equation and then solve for x. If I'm looking for a y-intercept, well, what does that mean? Well, y-intercepts are where it crosses the y-axis. When it crosses the y-axis, that means that x is equal to 0. So I'll take x and put it into there as equal to 0, and then we'll figure out what happens from there. So what we're really looking at here is we're looking at trying to develop an algorithm or an approach that will find us these intercepts. So let's go ahead and find these intercepts. I will find the x-intercepts first. Not because it's the right thing to do, but because since we're doing both, I'll just do it first. X-intercepts y equals 0. That gives me the equation 0 is equal to x cubed minus 4x. Because I'm good at algebra, I know to look at that and say factor it. So I have x times x squared minus 4. Clearly that's the difference of squares, so I will factor further. I have x times x plus 2 times x minus 2, and this is all equal to 0. Now I'm to the light blue there, and my next question is, what do I do next? Okay, so I've got it factored there in the light blue, but now what do I do? Let's see. Why do we factor? Well, we factor because of something called the zero product principle. And the zero product principle says that if two things or more, but two things are multiplied together and the answer is 0, so this is an if-then statement, then either A must be 0 or B must be 0. So the only way to multiply things together and get an answer of 0 is if one of the multipliers is 0. So that's why we factor. So we factor all the time so we can get to this statement right here where a bunch of stuff is being multiplied together and the answer is 0. And then we can say, well, for that to be true, either the first multiplier, just plain old x is 0, or the second multiplier, x plus 2, must be the 0, or the third multiplier, x minus 2, must be 0. And of course we would solve these and say x is negative 2 or x is equal to positive 2. So we factor so we can get to there, so we can do that. That's why we spend so much time factoring, to make use of that zero product principle. So what have we found? Well, where did we start? Well, we started out by looking for x-intercepts. And when we were looking for x-intercepts, we knew that we were looking for points, solutions, points on the graph where the y value must be 0, and we were trying to find the x value. And so what we found is we found three x-intercepts. One x-intercept is the solution point 0, 0. A second x-intercept is the solution point negative 2, 0. And a third x-intercept is the solution point 2, 0. So now that I've found my x-intercepts, I'll go ahead and do the next step, and the next step is to find the y-intercepts. Now the y-intercepts is when the graph crosses the y-axis, so that means that x must be 0. So what I'll do is I'll go ahead and put in 0 for x and see what happens in our equation. So I get y is equal to 0 cubed minus 4 times 0. So I get that y is equal to 0. So that means we have a y-intercept that is the point x0, y0. Now we'd actually already found that one over here. So you might be asking, why did I go look for it if I already found it? Well, what if there were other y-intercepts? They would have shown up somewhere in here in this math, and I would have found them. Okay? So now that I've found all the intercepts for this equation, I've done what they have asked me to do. I have found that this graph has 3 intercepts, 3 x-intercepts, 1 y-intercept, and one of those intercepts is actually both an x and a y-intercept at the same time. So we're at about 19 minutes. I'm going to call this video here. This will be part 1 of section 1.1. The next video will start here with symmetry of a graph.